I want you to imagine just a really incredible modern superpower.
Oh, I like where this is going.
Right. So you're sitting at your computer in Dallas, maybe you've got a coffee in hand, but instantly, with just a few keystrokes, you are controlling a machine in New York or London or Tokyo.
Yeah, you're just reaching across the globe in milliseconds.
Exactly. And that kind of unmitigated, instantaneous control, it's not hyperbole. It is just the daily reality of cloud computing.
It really is. It's how the entire modern internet is held together, honestly.
Yeah, and so for today's deep dive, we are unpacking the specific mechanism that actually makes all of this possible. We're looking at a really dense, compact guide called SSH in 3 minutes.
Which is a fantastic breakdown, by the way.
It really is.
Yeah.
So our mission today is to unpack this specific tool, Secure Shell, or SSH, and really understand why it's considered the ultimate remote control for the entire Linux and cloud computing world.
Right, because I think a lot of people hear Secure Shell and they think it's some kind of, hacker magic.
Yeah, totally. It sounds very intimidating.
It does. But what's fascinating here is that SSH is actually a foundational, fundamental protocol for managing just about any modern technology. It's calm, it's analytical, and it's incredibly structured.
Okay, let's unpack this, because if you are operating in the Linux ecosystem or the cloud, you are absolutely using SSH.
Oh, without a doubt, it's unavoidable.
And our source material outlines 4 primary functions for it. First, obviously, logging into remote computers. Second, running commands remotely. Third, securely transferring files. And fourth, just general server management.
Yeah, that covers the core utility perfectly.
And we see it used everywhere, right? Like from a cheap little Raspberry Pi sitting on a hobbyist desk all the way to massive AWS EC2 instances.
Right, and that actually highlights a really critical point about its architecture.
Yeah.
SSH is, it's completely agnostic to the compute power of the machine.
Wait, meaning it doesn't care if it's a tiny computer or a massive server?
Exactly. Whether it's that lightweight ARM processor in your Raspberry Pi or a massive multi-node cluster in an Amazon data center, the protocol functions identically.
Oh, that's really cool.
Yeah, you're basically establishing a secure, encrypted tunnel over the public internet, which is inherently insecure. And through that tunnel, you're just passing keystrokes.
So the way I think about it for the listener, think of SSH as an incredibly long, highly secure, completely invisible extension cord.
I like that analogy.
Yeah, like it just plugs your physical keyboard and your monitor directly into a computer halfway across the globe.
That is exactly what it's doing.
Yeah.
You're typing locally, and the remote operating system processes it as if you were physically sitting in that freezing cold server room.
But I mean, that level of access, that is exactly why we need to talk about the security implications, right?
Oh, definitely.
Okay.
Because you're not just like hitting a restricted web page that only lets you click a few buttons.
Right. You're getting a shell, you have full command line access, you could manipulate the file system or, change network settings.
Or completely wipe the entire operating system if you have the right privileges.
Exactly. You are effectively taking over the steering wheel of the machine.
Which is why the source material emphasizes that this level of access has to be treated so carefully. If you're sending root-level commands across the internet, the encryption has to be absolutely bulletproof.
So let's look at how we actually open this invisible, secure tunnel. Because knowing what it does naturally leads to, how do we execute it?
Right, the actual command syntax.
Yeah, and the anatomy of a typical SSH command from the guide is it's surprisingly brief. It's literally just Sasha Ubuntu at 192.168.1.50.
That's it. That one line is the whole thing.
Which we can break down into 3 parts, right? First, you have Sosh, which just starts the client program on your machine.
Yeah, it wakes up the tool.
Then you have Ubuntu, which is the specific username you want to use on the destination. And finally, that IP address, 192.168.1.58, which is where the remote computer lives.
Right, and if it works, you just get a command prompt on the remote machine. It's incredibly elegant.
But wait, I have to push back on this a little bit.
Sure, go ahead.
So I just type a single string of text, I hit enter, and suddenly I'm just inside another computer. It seems, I don't know, a little too easy.
It does feel a bit like magic when you first do it.
Right. Like, how does the destination computer know I'm actually allowed in? If it were that easy, wouldn't bots just take over everything?
Well, they absolutely would. And that's the crucial pivot here. The simplicity of that one command requires incredibly robust security happening entirely behind the scenes.
Ah, okay. So there's a lot going on under the hood to verify your identity.
Exactly. The sheer power of that squish command means we absolutely cannot let just anyone use it, We have to have a cryptographic handshake.
Which brings us to the whole passwords versus keys debate because, while you technically can use passwords with SSH,
You really shouldn't. Exposing a password prompt to the public internet is a massive vulnerability.
because bots can just sit there and guess passwords all day long, right?
Right, they'll throw millions of dictionary combinations at your server until they get lucky, which is why modern systems rely on SSH keys instead.
And the source defines an SSH key as a cryptographic credential for passwordless, secure authentication.
Yes, and it revolves around this concept of a key pair.
Okay, break that down for me. What is the pair?
So you have a public key, which you put on the remote server, and then you have a private key, which strictly stays with you on your local machine.
So here's where it gets really interesting for the listener. Think of the public key as a custom padlock.
Ooh, I like where this is going.
Yeah, so you take this custom padlock and you send it to the server. You can give a padlock to anyone, it doesn't matter. But the private key is the physical jagged metal key that you keep strictly in your own pocket.
Right.
And that physical key is the only thing in the universe that can unlock that specific padlock.
It is a perfect way to visualize it. And the beauty of this is that it completely eliminates the vulnerability of easily guessed passwords.
Because there is no password to guess.
Exactly. The math is absolute.
Yeah.
And the source uses the AWS EC2 example to show this in action.
Oh, right, the -I option.
Yes, the II flag. When you connect, you literally type II and then the name of your key file. You are explicitly telling the SSH client to use your specific private key.
And without that exact correct private key, the connection absolutely will fail, right?
Without question. It's a mathematical wall. If we connect this to the bigger picture, the entire security of your infrastructure relies entirely on you protecting that private key file on your local machine.
Okay, so that's when things work perfectly. But let's be real, even with the perfect jagged metal key, things don't always work.
Oh, definitely not. Network friction is a very real part of the job.
Yeah, so what happens when a listener tries to connect and the system just pushes back? The source material breaks down 3 very common problems, or failure states.
Right, troubleshooting is a huge part of learning SSH.
So the 3 errors are connection refused, permission denied, and timeout.
And each one tells you something very specific about where the breakdown happened.
Okay, let me ask a clarifying question to help visualize this.
Yeah.
Going back to our analogies. So, if I'm trying to get into a house, a timeout means the remote house is entirely hidden behind a massive wall.
Yes, exactly. A timeout means a firewall or a security group is actively blocking your access. The server doesn't even know you're knocking. The packets just vanish.
Okay, and connection refused means you can clearly see the house, but the front door is completely bricked up.
Spot on. The network routing worked, you reached the IP address, but the SSH service simply isn't running on the destination. There's no daemon listening to let you in.
Which leaves permission denied. So that means you're standing right at the door, but your key just doesn't turn the lock.
You've got it. You reach the door, the service is running, but the username or the SSH key you provided is incorrect. The server looked at your key and said, nope, not authorized.
That analogy actually makes those errors way less frustrating.
It really does, because those errors aren't actually the system breaking down. That is the system functioning perfectly. Those are security boundaries protecting the server from unauthorized access.
Right, it's doing its job. And speaking of permission denied, the text actually calls out a very specific common mistake that triggers this.
Oh, the username trap.
Yes. Yeah. So if you're used to Ubuntu, you might just naturally type Ubuntu at and then the IP address. It's just muscle memory.
Right, but if you do that on an Amazon Linux instance,
It totally fails because Amazon Linux instances expect you to use EC2 user instead of Ubuntu.
Exactly. Your key might be perfectly valid, but if you're wearing the wrong name tag, the server will slam the door in your face. Permission denied.
It's such a tiny detail, but it will absolutely stop you in your tracks.
It's a rite of passage for every systems engineer, honestly.
So true. So as we pull back and look at the big picture here, we need to revisit the core thesis of the source material.
Which is that SSH really is the definitive remote control of the Linux world.
It is. Whether you are, just tinkering with a Raspberry Pi in your living room, or you're managing a massive fleet of AWS EC2 instances and Ubuntu servers in the cloud, SSH is the absolute first tool you will reach for.
Without a doubt, it's the standard.
And the final encouragement from the text is just so validating. This is a highly leveraged skill.
Oh, incredibly leveraged. If you learn the quirks of SSH once, you will rely on it for years, maybe decades to come.
It's an investment that pays off every single day. But, before we wrap up this deep dive, I want to leave you with a final kind of provocative thought to mull over on your own.
I love these. Laid on me.
Well, we've established that SSH keys are the absolute, undeniable keys to the kingdom. They protect everything from your little home server project to massive corporate cloud databases.
They are the ultimate VIP pass.
Right. So, what happens if you accidentally delete your private key file?
Oh, that's a nightmare scenario.
Or, infinitely worse, what happens if someone else gets a copy of it? If that mathematical lock is absolute, just how secure is the digital pocket you keep your keys in?
That is a very unsettling question to end on.
Something to think about next time you log in.